All right, so you've made it to the very last video of the course. I thought I would be in my office and look professional, makeup on. Um, let's do this. You made it through. All right, so I'm gonna show you how to solve quadratic functions several ways, like all the ways we learned, and show you how like there's different ways to get to the same answer. Okay, just like you might be going to your friend's house, but sometimes you come from the grocery store, sometimes you're picking up your kids, sometimes you're coming from school, sometimes you're coming from your house. You still get to the same spot. And so, or sometimes you're coming from your house to your friend's house, but the way you normally go has construction or there's a wreck, and so you have to take a different route. And so that's why there's several ways to go depending on which way may be easier or less troublesome. All right, a couple of notes. The word zeros, x-intercepts, roots, and solutions, they all mean the exact same thing, all right? And so if something says solve, like solve a quadratic function or equation, you're finding the zeros. It's called zero because it's the y value is 0 on the x-axis. You're finding the x-intercept because it's on the x-intercept. It's on the x-axis when it crosses. You're finding the root of the equation. You're finding the solution of the equation. All right, quadratic formula and completing the square always work, but they're longer, but they always work. Okay, it's like I-35 from San Antonio to Austin will always get you there, but sometimes it's like crazy traffic. Or especially like I-35 to Dallas. Jesus, we are BFFs, okay? I got to take my girls to Dallas all the time, and I really hate I-35, but it will always work. Sometimes I try to go around and take different side roads because I just can't stand the traffic and the pileups, but it'll get me there every time. All right, factoring is my personal favorite, but it doesn't always work because, excuse me, everything can't be factored. All right, these guys, quadratic formula and factoring and completing the square, those guys work when it's in standard form. Okay, in standard form looks like this. When it's like that, when it's like x squared plus 9x plus 20, right? Graphing and taking the square root, different color, these guys work when it is in, let's get a different color, when it's in vertex form. So that's like x minus 2 squared minus 16. All right, so just some notes and tidbits. Also, I would tell you this. I personally use quadratic formula when A does not equal 1. So like when there's a number right here, there's a number right there. So I don't know, 2x squared plus 9x plus 20. That's just my kind of go-to. Completing the square, I use if a is 1 and it can't be factored. But those are just my kind of go-tos. All right, so I'm going to solve this by factoring. Let me get color we can all see. All right, and so first we got to set it equal to 0. So I'm going to move that 27 over. All right, so what I really have is x squared plus 6x minus 27 equals 0. All right, so we got to figure out multiplies to give us negative 27, adds to give us 6. All right, let's try 9 and 3. But 6 is positive, so 9 is positive. Let's try 3. All right, 9 times negative 3, negative 27. 9 plus negative 3, 6. All right, so what we really have is x plus 9, x minus 3. All right, these right here, what's in parentheses, called factors. Okay, and then now let's solve it. So I'm going to do x plus 9 equals 0, x minus 3 equals 0. All right, so I'm going to subtract 9 on both sides. So I get x equals negative 9. Then over here, I'm going to add 3 on both sides. And I get x equals 3. All right, then these guys right here, x equals negative 9, x equals 3, those are called the solutions. Intercepts, those are called zeros. These are called the roots. Okay, so all those 4 words mean the same thing. Notice that the factors and the solution, like it's plus 9, negative 9, negative 3, plus 3, kind of opposite. Just notice that pattern for a minute. All right, let's do our next problem. All right, solve by quadratic formula. All right, remember, this is really x squared plus 6x minus 27. Let me make this a little smaller. And then our quadratic formula was negative b plus or minus square root b squared minus 4ac all over 2a. Right here, a is 1, b is 6, c is negative 27. All right, negative b, so negative 6, that's hard to read. Negative 6 plus or minus square root, that's a plus. B squared minus 4 times A times C all over 2 times A. All right, and so remember, I'm going to take this guy, that guy, the discriminant, 6 squared minus 4 times 1 times negative 27. I'm going to pop him in my calculator, just as it is. Don't put the square root. All right, so I get negative 6 plus or minus the square root of 144 over 2 times 1 is 2. All right, the square root of 144 is 12. Right, so I have negative 6 plus 12 over 2, and I have negative 6 minus 12 over 2, because I have that plus and minus. Remember, I'm going to get 2 answers because of that. If there was an x cubed, I get 3 answers, x4, 4 answers. Just a plain old x, I get 1 answer. All right, negative 6 plus 12 is 6, divided by 2 is 3. Negative 6 minus 12 is negative 18, divided by 2. Negative 18 divided by 2 is negative 9. All right, let's look, because remember, this is the same problem we just did. So 3 and negative 9. Let's compare that to what we got on the previous problem, and we got negative 9 and 3. Same thing. So we just, different direction, different path, but we get the same answer. If our math is right, it's going to work. All right, now let's do completing the square. So we're going to do x squared plus 6x plus blank equals 27 plus blank. Remember, in that blank goes b over 2 squared. B is 6, so we're going to do 6 over 2 squared. 6 over 2 is 3. 3 squared, 9. So I'm going to put 9. All right, now I'm going to write this, and then in this spot, put b over 2. So I'm going to put x plus 3, because that 3 is positive. And then 27 plus 9 is 36. Okay, I have to take that square root, because I'm going to get rid of that squared. So the square root of 36 x plus 3 equals, when you take the square root, not the square root, you do plus minus 6. All right, so I have x plus 3 equals negative 6. X plus 3 equals positive 6. All right, so I'm going to subtract 3 here. I'm going to subtract 3 here. All right, so 6 minus 3 is 3. Negative 6 minus 3, my bad. Negative 6 minus 3. Negative 6 minus 3 is negative 9. Sorry, I don't know why I had issues with that. Remember, I'm not perfect. I just don't give up. 6 minus 3, 3. So we got negative 9 and 3. Let's compare it. Negative 9 and 3. Let's do another one. All right, now we're going to do this taking the square root. All right, so first we need to set it equal to 0. X minus 2 squared minus 4 equals 0. All right, then I need to add 4 because you got to get the square all by itself. X minus 2 squared equals 4. All right, we got to take the square root because the square and the square root are inverses. So x minus 2 equals plus minus 2, because when you take the square root, plus minus. So we have x minus 2 equals negative 2. X minus 2 equals positive 2. So I'm going to add 2 on both sides because I want opposite operation. I want those to cancel. So I get x, negative 2 plus 2 is 0. 2 plus 2 is 4. So I get 4 and 0. Okay. Now let's graph. So when we graph, all right, this guy says the vertex is 2, negative 4. So 2, negative 4. And he's going to open up. And he's going to move right 2 down 4 from like our original guy at the center at the 0, 0. Okay. So let's graph it. So if we notice when we graph it, we get 0, 4, which is the same as 0, 4 as our x-intercept. Right now we can use any method. I'm going to do 15. I'm going to do factoring. So because I like factoring, we can do 5 and 3. X plus 5, x plus 3. So x plus 5 equals 0. So we get x plus negative 5. Notice that the factor and the 0 are opposites. X plus 3 equals 0. So we get x equals negative 3. Notice that it's plus 3 and minus 3. They're opposites. Why it's the same problem. Any method. All right, so I'm going to do negative 3 times negative 5. I get negative 15. Let me pause this, and in the next video, I'm going to solve it because I don't want to run out of time. So I'm going to restart this problem in the next video.